So this is the demo video that corresponds to the talk Programming in Lisp on the Pi given at CamJam8 in September 2014. And it's just to improve on the screen resolution of the text of the demo in the actual video. My screen size was a bit small to be able to see what I was typing, so hopefully this will improve things. What we're looking at here is Racket running on a Raspberry Pi, and the environment is Emacs, which is talking to a copy of Racket. As mentioned in the slides, Racket has its own IDE, but for use on the Raspberry Pi this setup is a little bit snappier, but it's worth trying both to see which you get on best with. So Racket being a Lisp, you might be able to expect that you'd be able to type things like this. In Lisps, very often the way in which you write expressions is that they're enclosed in brackets, and the first item after the opening bracket is an operator, and the things it operates on are the next items in the list there. So if we do that, execute it, sure enough we get the result 4. And we can define new functions in Racket by saying something like this. Which adds 2 to whatever number we give it. And so that's what you'd expect. One thing you might not have seen before if you've not used Racket is something like this. And it's quite nice in that the execution environment here will display graphics in the running transcript. Okay, so since this talk is really about traffic lights, that little green circle gives me a clue. What if we try and think of drawing a traffic light? So here we're using a graphic primitive called above, which will draw several graphics objects one above the other, and so we call that simple traffic. And sure enough, if we execute that, we get something that looks like a traffic light. There are other graphics primitives, and there's this one here, star polygon. If we execute that, we get an image that looks like that, and that you might regard as something looking like a traffic light whose light is lit. So we can do something like this, defining a function called light, which takes a particular color value and a true or false value to say, is this traffic bulb lit? And if it is, it draws the star polygon you see below, and if not, it draws a standard circle, so something that's not lit. So if we try this function out, we're going to draw a red light that is in fact lit. And we get that. Now that looks the same. Let's just turn that off. Sure enough, we get a turned off red light. So if we want to draw a complete traffic light, we can define fancy traffic, which takes red, yellow and green values and draws the corresponding picture. So here we have a traffic light which has got the red and yellow lights lit and the green light not lit. Sure enough, that works. Now, traffic lights cycle through 4 stages in the UK. So there are 4 states. State 1 is just red, state 2 is red and yellow, state 3 is green for go, and state 4 is yellow to warn you that the traffic light's going to go cycling back to red again. And this function takes the state and a way of drawing that state as a traffic light, and depending on which state it is, it produces the correct picture. So if we say a traffic light which is in state 1, we get the red light lit. State 2, red and yellow, and so on. And so if we wanted to see a sequence of all the possible states of a traffic light drawn as an image, we could do something like this. So we're using a graphics primitive called beside, and that will draw 2 graphics items, one beside the other. And so if we want to draw the complete sequence, we get that. Okay, so that's so far so good for drawing images on the screen of the traffic light. Now let's do the same thing in the real world using the pi stop traffic light. The pi stop is a little unit with 3 LEDs, red, yellow and green, arranged like a traffic light, produced by Fortronics. And it's really good for live demos. And what I've done is I've written an interface between Racket and the Wiring Pi library, which is a commonly used library for interfacing with GPIO on the Pi. It's written by Gordon Henderson. So if we look at the Racket code, which is designed to drive the Pi stop, there's a bit of setup the function at the top of the screen here, which first of all sets up the GPIO to be operating in the correct way, and then turns all the LEDs off. This is for each of the LEDs in the Pi stop. It turns them off. And in order to connect the Pi stop with some of the stuff we've just done in the graphics world, I've just defined a new function here called Pi stop traffic, which, if you remember, mirrors the operation of the function defined for graphics. So we give Pi stop traffic a red, yellow and green true or false value, and then depending on the values of those, it actually performs the write to the I/O ports to set a particular LED on or off, so for red, yellow and green. And so what we can do then is we can, instead of using the fancy traffic function which drew to the graphic screen, we can use Pi stop traffic and set the Pi stop in a particular mode. So if we do that, we'll get the Pi in mode 2, and we can change this to state 3. state 4. And back to state 1. And finally, we might want to actually cycle through the traffic light sequence, and this function defines a function called PyStop sequence, which one by one puts the traffic light through a set of states, 1, 2, 3, 4, 1, 2, 3, 4, so it repeats 3 times basically. And then if we try that, sure enough, the traffic light behaves how we'd expect it to. So I think that shows the way in which, just by changing one function, dropping a particular function into the traffic light function, we can either operate in the graphics world or on GPIO on a PyStop real world LED traffic light.